So I'm looking at a file here. Actually, it's pretty easy to duplicate it. Let me do this. So, trying to get it to run, I got a main. The problem in this case is that, still give me fits. I meant to give this a different name. This file may not actually be part of the project. If you double click on this over here, solution.cpp, you may find that it's either empty or that it's got a different version of the file than you were expecting. In which case you go back to the one that you're really working on and paste it into the one that shows up in Solution Explorer. Because if it's not in Solution Explorer over here, it means that it's not being linked. So if the linker doesn't run, then the main.cpp cannot be part of the executable. Alrighty. When you mix apples and oranges, type conversion. Operations are performed between operands of the C type. Same type, not C type. That means that if you do something like this, you know, x is equal to a times b, this operator here is going to work on two things of the same type. If they're not of the same type, the compiler fixes it so that they are. So if this is an int and this is an int, great, the result's going to be an int. If this is a float and this is an int, then it's going to convert the int to be a float, just because the compiler wants them both to be floats before they could be multiplied. The math for doing floating point multiplication inside the chip is different than the math for doing integer division, multiplication, especially division. I think we talked about division rounding down. Maybe I didn't. We certainly will in just a moment. So if we did this, int a is equal to 4, int b is equal to 3, and then we did x is equal to 4 divided by 3. The division symbol is the operator. We have two operands. They are both integers, so it's going to do integer division. Integer division produces a whole number. Rounding down. I'm pretty sure we mentioned that already. Not totally sure. But we talked about, you know, modulus, right? Okay, so what is 4 divided by 3 rounded down? Yeah, so x would equal 1. However, say that one of these had been defined as a float. So int a is equal to b, double b is equal to 3, x is equal to 4 divided by 3. Well, one of them, I'll just put a 0.0 in there to make absolutely clear that it's a floating point. One of them is a float. That one's a float, so this one gets turned into a float in order to work. And then it does floating point division. And 4 divided by 3 is 1.333, whatever, you know. Floating point division doesn't round or produces a floating point number, so x would equal 1.333, etc. to whatever precision x is defined as. Now, if x was defined as an int, then the answer is not going to be 1.333 once it gets stored in it, because you can't store a fractional number in an int, even if you try. If you do this, int I is equal to 3.3, it's not going to work. In some compilers, it would just flat out produce an error. In others, it'll do it, but it'll go ahead and round it down. I believe that's the way Visual Studio handles it.
If you're doing like a GPA, why, I'm kind of confused on why float wouldn't slide for the GPA, because isn't it just 2 decimal places?
Float for GPA. A float would be what I would use for a GPA, because you have 3.8 or 2.97 or whatever. So it's a floating point, so you absolutely would want to.
I thought I tried to do that. Maybe it was in Java. I don't know.
So for stuff like payroll, and GPA and anything that has a decimal, you're going to want to store, your data points as float, as double, really, in order to get them to work. So operations are performed between operands of the same type. If they're not of the same type, C++ will convert one of the types to the other. This can impact the results of calculations. We saw that when one of them was a float, we got a dramatically different answer. We got 1.333 rather than 1. Now, hierarchy of types. Int is the lowest. Long double is the highest. Long doubles can hold vastly larger numbers than anything else. Floating point numbers can hold larger numbers than integers anyways because they have that exponent. 1 to the times 10 to the 99 is going to be vastly larger than the 2 billion or 8 billion, whatever it was, that's the largest value of an int. So, when numbers are converted, they will get promoted. What do I mean by that? If you have long L is equal to 3, and then you have int I is equal to 2, and then you do x is equal to L times I, they are not of the same type. So one of them is going to get converted to the other one. It's not going to try to convert that L to an I, because what if this was a big number? Like that. You could lose data, that's larger than our billion, limit for an int. So instead, the I gets promoted to a higher type, to a long, in order to do that. The int gets promoted to a long in order for it to work. I don't care if you know these unsigned ints and these doubles and stuff like that. Just know that ints are basically the most inferior data types, then longs, and then floats, and then doubles. Any integer type is inferior to a floating point type for the reason I just said. Exponents can make numbers vastly huger. And, well, for one thing, a long is the same thing as an int in this dang language. What if it was a long? I still believe that to be the case. But things get promoted. Doubles will not be converted to ints automatically. Floats will not be converted to ints automatically. Longs will not be converted to ints automatically because, again, if that happened automatically, you could lose data without being told about it. If you did this, long L is equal to 4, and then you did int, and you did int I is equal to L, that's great, that'll work. It won't work because this data type cannot be automatically demoted to fit into an I. You can force the issue, though. You can say, oh, by the way, I know better. I really want you to do it. I'm pretty dang sure that L is never going to be so large that it won't fit into an int. So you can do that. This says, no matter what, I want you to modify that value so that you can store it into an int. Works with floats, too. If you do double D is equal to 3.14159, and then you do int pi, that's stupid, int x is equal to D, that's not going to work. I hate saying it's not going to work because if I stick it in a compiler, it'll probably work. Just pretend it's not going to work. Yeah, demotion should never happen automatically. And I absolutely know that in some languages, like C# and Java, it will not let you do it. And if C lets us do it, then it's kind of an error. Instead, you have to do this. I know you're a double. I know that you're a 64-bit data type, but I want you to fit into a 32-bit data type. Do whatever you have to do. And if the number is larger than 2 billion, so be it. It's going to be corrupted. It's not going to be an accurate number anymore. So this is known as casting. The int thing is known as casting. What does casting mean? Well, if you have metal and you want it to be in a different shape, you get a cast. You pour the metal into it. When you melt it, you pour the metal. It's a different shape when it's done casting. What if you have more metal than will fit in the cast? Well, you have some excess metal, and you throw it away or something. Same idea. A long would not fit into an int, so there's a possibility that data will be lost. A double or float will not fit into an int, so again, there's a possibility that the data may be lost. On the other hand, you probably know the range of your data, and if you want it to happen, then you can do it. You can do casting. You can also cast, to floats or whatever. This is kind of dumb. You don't need to do this. Float f is equal to I, if I is an int. You don't need to do that because this is a promotion. You can always promote data safely. An int can easily fit into a float. Absolutely no problem. So, no problem. You don't have to do this. But, you could think of it like that. I is going to get converted to a float and then be stored in F, but it's happening automatically. They also mentioned demotion, and I don't know of a time. Okay, type coercion. Type coercion is automatic conversion of an operand to another data type, and that's what we've been talking about. You have a double and you have an int. Which one is going to get changed if you have a double and an int being multiplied together? The int's going to be changed. They're both going to be doubles. That's called coercion. The int changed to a double. It was promoted. Demotion, I don't know whenever that happens automatically. Demotion is what you use casting for. So char, short, and unsigned shorts are automatically promoted to int. When operating on values of different data types, the lower one is promoted to the type of the higher one. When using an equal sign, the type of expression on the right will be converted to the type of the variable on the left. That kind of implies you don't actually need casting in order to get it to work. I would put the cast on there anyways. This chapter doesn't mention casting for some reason. I do not believe. You'll hit it again. And then you probably won't use it in the class actually. But you'll probably use it as a professional programmer in another language, if not this one.
What would be the purpose of it?
You read data in, and somebody decided that all of the values for age needed to be stored as floating point, and so you read it all in, but then you're going to write it back out in a format where it's expected to be an integer. You just convert it to an integer before you write it back out. That kind of thing. If your data is floating point, but you need to pass it to a function that only accepts an int, then you convert it to an int. And yeah, you risk, rounding it down or whatever. And that's just kind of the problem. That's kind of what you have to accept. Overflow and underflow occurs when assigning a value that is too large or too small to be held in a variable, in which case it, quote, wraps around. It floats. Let's just give a demo of that. I'm going to make a new project. And I wouldn't mind if y'all type this in with me. Add new item. CPP. Okay, this is going to be an example of overflow. # include IO stream. Hopefully you have a boilerplate file you could copy. I'm pretty sure this isn't going to involve strings, but I'm going to include it anyway. Then I'm going to do a using namespace std int main. Alrighty, that stuff, and then a system pause. Now I am done with my boilerplate. Okay, so what if I take a number that's an int and I assign it a value of x? And now I'm going to do something that we really haven't talked much about, but I'm going to write a loop. And it's going to be in the form of an infinite loop, meaning that there's no way out of it. The way a loop works is you have a while, and then you have some condition here. While, x is less than 10. Keep doing this stuff. It's like an if statement, except when it's done with the if, it repeats itself. And it keeps doing it over and over and over as long as this condition is true. If that condition ever becomes false, then it falls out. So if we did this, while x is less than 10, print x, C out x, and then x is equal to x plus 1, which would be better expressed as x plus plus, like that. Then it would count 1, it would add 1 to it, 2, 3, 4, 5, 6, 7, 8, 9, and then when x became 10, 10 is no longer less than 10, it would fall out of the while loop and it would go to the pause and press in the key to continue. So that's a while loop. But I'm going to write an infinite loop. I'm just going to say while true. That means keep repeating no matter what. So I'm going to keep doubling the value of x. X equals x times 2. C out x. X is going to get pretty large pretty quick, right? 10, 2, 4, 6, 8, We're going to go through all the powers of 2. It's going to get too large to fit into an int as soon as it's more than 2 billion, whatever. Alrighty. I broke it. We can't even see at what point it broke. That's too bad. I guess I'm going to put another if statement in here. While x I still want to do it like that, but then I want to do something sneaky. If x is equal to 0, less than or equal to 0, then break. A break forces it out of the loop even if the condition isn't true. And we're going to hit these topics again when we get to the chapter about loops, which will not be very long. This should show us at exactly which point the data gets too large to fit into an int. Here we go. There's our powers of 2. 2, 4, 8. Okay, you see what happened? It went negative. It's just because it's invalid data at that point. The real reason it goes negative is because since this variable is not declared as an unsigned variable, bitwise, the first bit in an integer represents a signed bit. And I'm going to show you what I mean by that, and it's not absolutely true what I'm going to say, but conceptually this is what I want you to know. If I have a 4-bit number, what am I doing? There's no such thing as a... Have we talked about bits? A little bit, no pun intended.
Would there be any reason mine would just be printing 0?
Right, mine did that too until I put that break in there. So, did you put that in there?
No.
Yeah, put that in there. It'd be fun to make this say if x is equal to 0 break, because we'd see how corrupted the data got before it just got so confused it said x was equal to 0. I'm going to do that. Well, okay, the very next thing it does is it turns to 0, and I can't quite explain that. But what is happening? Why does it freak out? Because the first bit is the sign bit, and then the next 3 are the magnitude. Now these integers are actually 32-bit numbers, so that means that the 31 bits of it are devoted to data, and then the next one is a sign. What do I mean by that? The sign bit, if it's 0, it's a positive number. If 1, it's a negative number. So here we go. We have, 0, 1, 2, 3, 4, 5, 6, 7. But yeah, once you get there, it's a negative number. It looks like it would be negative 0, but instead they do something called 2's complement to avoid getting negative 0. But that's the concept of it. So, you know, these numbers are negative. Let's look up 2's complement values so that I could write them down exactly. It's all right if you don't. I want it just to trigger in your head, and then if you ever really have to understand it, you can.
So, well, like what we're looking at, we're not looking at like binary, right? 'Cause
It is binary. The zeros are binary, right?
Well, I thought one, like if all the bits were filled up, it was.
That's if it's an unsigned number.
Okay.
So here, all the bits are lit up, except the first one is just a flag. So if that was a 1, we could pretend that it was a -7. If that was a 1, it'd be a -6.
Okay.
And if that was a 1, it'd be a -5. Now it's slightly different than that, really. The numbers I'm giving you are one off, but ignore that because that's the concept of it. Just know that in reality they're stored as 2's complement, which is one off from these values, just to avoid this being -0, because that's a waste of, you know. But anyways, okay. So any number larger than 1,000 is a negative number. So what's happening? Each time we multiply by 2, that's a 1, that's a 2, that's a 4, that's an 8. It flips to being negative. So that's called overflow. So overflow is when your data exceeds the capacity of the data type to store. Does it blow up? Does a computer crash? Well, probably not, but you get weird things like a Pac-Man kill screen. Which is where on level 256 it generates that screen.
Wow.
Because it hits 256, but it was an 8-bit an 8 bits were devoted to counting the level. The highest number that 8 bits, if it's unsigned, can hold, 11111 all the way across, is 255. So when it hit 256, it goes, oh, that's a 0. I'm now on level 0. And the guy who programmed it never expected that any idiot would be able to play that long. So there was no, you know, it was just corrupted. It would be an easy fix to do whatever you needed to do, you know, go inside it and fix it. But
That's what the end of the game looks like?
yeah. So you can go ahead and eat all the dots that are there, but you can't finish, you know. That's why it's called a kill screen. Donkey Kong has a different kill screen, where your character just dies the second the screen loads up. So, you know, poof, nothing hits them. It's just, you know, so there are limits to these old games, some of them, you know, to how far you can play. And so people try to get perfect games. I'm going to eat every dot, eat every ghost absolutely perfectly, you know. The first person who did that, yeah, I'm the best. Then I guess, anyways.
So much time. So
Yeah,
much
uh-huh.
time devoted.
Yep. Okay, so overflow does have real-world consequences, more important than Pac-Man. So you always want to choose data types that are comfortably large enough to hold the data that you're working with. If your number's not going to get bigger than 2 billion, ints are great.
Didn't you tell us about the national debt clock or something like that, or something? Like it was show like it was holding national debt, but once it reached a number that it couldn't hold anymore, it screwed up. Or something.
I don't think I showed you that. I'm going to have to look that one up.
Where did you get that from? Maybe I was looking up something, but yeah, they were saying that once it reached a number that the programmer didn't program it to hold it.
Yeah.
Just messed up.
Okay. So, ints, smallest data type conceptually. Doubles are the largest. Data will be promoted from a smaller type to a larger type automatically when needed. But then if you're storing it back into a smaller data type, you'll wind up with overflow perhaps. You know, if that number, if your answer was larger than 2 billion and you try to store it back into an int, it won't fit. Different systems may display a warning or an error message, or they may stop the program, or they may continue execution using the incorrect value. That's kind of the worst case. Typecasting, I was wrong, they actually do it. They show a different syntax for typecasting. I showed you the original C syntax, not C++, the original C syntax. And the reason I did that is that convention has also been used in Java and C# and a whole bunch of other languages, whereas this funkier syntax that I'm about to show you is very C++ specific. So typecasting is used for manual data type conversion. Useful for doing floating point division using ints. For example, if you have a number here and you have a number here and they're both ints, but you didn't want it to be rounded down, you could cast one of them to be a double before you did your division. Also useful to see the int value of a character variable. I don't think we've talked about ASCII yet in this class. I know we have in another one. But a capital A in ASCII is stored in memory as the number 65. And there are ASCII charts you can look at. Okay, ASCII stands for American Standard Code for Information Interchange. Anyways, you look up an ASCII chart and you will see that A's are stored as 65, B's are stored as 66, C's are stored as 67, lowercase a's. So anyways, yeah, we're curious about that. We want to know what that is. Let's go back into our thing. Make a character here. Tell you what, let's do some input. Character CH. And then C out, type a character, and then hit enter. And then we'll read in a character, C out, oops, CIN, error CH. Now let's print it out. So C out the character, but also C out a space. I did the arrows the wrong way. C out the character, but also C out a space, and then lastly, print out the integer version of that character, and then ENDL. And I'm going to put more spaces in here to make it real clear what it's doing. If we type a capital A, it ought to print a 65. And then it's going to still do that overflow thing. Oh, I wasn't expecting that. Why did it print a smiley face? It thought I typed Control A, I think. I'm going to do that again. That was kind of odd. Type a character. A, hit enter.
Yeah, mine did 65.
Okay, that time it worked. This keyboard, in an earlier class I was teaching, always giving me fits. It still is. Okay, so if you type a B, it's going to say 66. If you type a space, I'm not sure it'll work, but it should display 20. No. Whatever the ASCII value for a space is. So you use casting. Use casting to convert from one data type to another when needed. Chars to ints, floats, or ints to floats, so that you can do floating point division. Let's prove that to ourselves that that can actually work. We eventually fill these programs up with so much that, you know, anyways. Okay, so int x is equal to 3, int y is equal to 2. C out, if we just do x divided by y, I'm going to put that above. Oh, I already have an x here. All right. I'm going to put this stuff above our current code so that we can just break, you know, we can just close the window after it runs. Oh, ENDL, excuse me. So that's going to be 1, because 3 divided by 2 when they're both integers is integer division. 1. All you have to do is turn one of them into a float, or a double. So, like that. X divided by a floating point version of y.
So I'm guessing the casting works both ways, because when I was typing, when you did like when you showed the ASCII value and that cout, I did int x like how you would do like in Python, and it still ran, but like in Java, if you try to do that, it won't let you do it. Is there a reason it lets you, like instead of putting the parentheses around int, you can put it around the character, and it'll show the values still, instead of.
I would have to see that. I don't know if you have it typed there or not. Okay, let me see. Oh, that works. That works. Just like Python.
Yeah, but
That worked for you, right?
But
Okay.
in Java, like I was trying to do,
It doesn't work in Java.
It doesn't work in Java.
Right, right. So that's why I'm showing you this syntax, because this syntax works in Java and C#. Point is made, and it's quite true that there's more than one way of casting. You could also do it like this. Cout int version of ch. That's the same as doing cout the int version of ch.
Is ASCII the language that has the codes that you can type in, and it's like alt 0, 1, 2, 4, whatever, and you can type that in, and then that'll give you the character then?
There are programs that'll do that, yeah.
Is that, like you can do that on, like, I think on Word you can do it.
Right, right. Where you hit Alt 1, 2, 3,
Right.
and it turns into a
Is that
character.
the
That's it
language
exactly.
that references?
That's it exactly. So if we do the opposite, if we say ch, because ch is a character, right, is equal to the character version of 65, and then we print ch out, it's going to print an A. And so what's a cool alt code? Hopefully y'all know what I'm talking about. Alt, you know, like alt 1, 2, 3. Well, that certainly was not what I expected to see. Alt 1, 1, 1. Neither that. 1, 3, 5. Okay, there. 1, 3, 5 is a little cent sign, upside down cent sign. So what I'm doing is I'm holding the Alt key, I'm typing 3 numbers, and then I'm letting up. So set, do this. Ch is equal to character version of, was that 133? Then I just said, well, okay, that's an A with an accent above it. Great. And then see out that. You'll see that we have converted a number into the character equivalent of it. There it is. It's the A with the backward accent. Now, Alt codes that you key in on the keypad can be larger than the character set that we're dealing with now, because they support Unicode characters, and Unicode is 16 bits wide rather than 8 bits wide. 8 bits can only store, you know, Western languages and stuff like that, you know, all the letters and, you know, the numbers and stuff like that. But they're more in the world than just English. You know, you have Swahili and you know, the different flavors of Chinese and Japanese and whatever. So those require more than 256 different spots, which is the most that you could hold in 8 bits. So Unicode is a 16-bit one so that you could have everything in it. And the alt sequences support those. There are some funny little symbols that are in the alt codes as well. Pop open Notepad.
Just holding Alt.
Yeah, let's do this again. Alt, and then make sure your numeric keypad is enabled.
Oh.
It's hard to do if you don't have a numeric keypad on your laptop, but make sure the numeric keypad is enabled. Hold Alt, type in a number like 144, and then let up.
Oh, okay. I was trying to use the.
Oh yeah, if you use the numbers along the top, it doesn't work, so you have to use the numeric keypad. And you can just play with that, like what's an Alt 500? Cool. What's an Alt 600? An X 900. 0110. You know, whatever. All of these things are part of Unicode.
Alt 2 is the smiley face. I think.
Yeah. Alt 3 is a heart. There you go. I don't know how to do those on a Mac. This is a PC trick. Okay, so that's casting. I want you to memorize this version of it. If you want to use this version as well, that's cool because it works in Python. Let me cut and paste these into our notes. So this is the old school style. That's the one that I really want you to memorize the most. This is new school. Old school works in whole bunches of languages, C, C++, Java, all sorts of things. This one works in C++ and Python, and then there are some weird ones, which this shows. Static cast. I think static cast is way overkill. What static cast lets you do is change class objects from one object to another. And we're not dealing with classes. Doubles and ints and things like that are just primitive data types. They're simple data types. So I don't see why we would need to do that. But we'll go ahead and write it down. If that's the third form of casting.
String is a class, right?
Yes. So I'm going to static cast that CH to be an int. That's also new school. 3 different ways. Are there even more ways? Yeah, fortunately the textbook doesn't get into them. If you become a C++ guru, you can find other ways of casting. Memorize the first method for our exams. You know. I don't think I'm going to actually give you any homework that requires casting. So it's just something you're going to have to tuck away. And since our books, our quizzes, our exams and everything are open notes and whatever, if I use the word cast and you've forgotten it by then, Google it. When you do these exams, don't feel like you have to be macho and do it without the book. And what I mean by that is sometimes I see people miss questions that I absolutely know they knew they didn't know, but they didn't take the time to look it up or whatever. And so especially if you're going to do it at home, then you know, you have time. Now, if I gave you an exam that was too long to be done in an hour and a half or whatever, then it's my fault. I have learned that lesson. Didn't I do that in the scripting class, give you all exams that were impossible to complete in the time? I forget.
No, I'm pretty sure I did.
You got yours done? Okay. Some class I did, I kept overestimating. And that is not my goal. I do not design my exams to be killer. You know, people use exams for different purposes. Some people use them to evaluate, you know, to judge. I like to use them as a learning tool. That's why I let them be open book, because if you see things on the exam you don't know, you learn it right on the spot. You don't have any choice but to learn it if you want to get a good grade on it. So they're learning tools. I had a professor here a while back who just flat out wanted to not give any exams at all, but the department required him to give exams. His point was that, you know, if they can do the homework, then they ought to make a good grade. But nope, exams are required.
At that point, I wouldn't let exam tear up the exam you pass.
Yeah, I'm going to give you an exam, but it's only worth 0.1% of your grade. Alrighty, so these are known as C-style and pre-standard type. The C-style cast is to do that. The pre-standard C++, whatever that means. And then both are still supported, although static cast is preferred. Okay, fine. That's what they say. Multiple assignment and combined assignment. If you want to, you can assign a whole bunch of values at the same time. What do I mean by that? Well, you say you declare 3 variables. Int height, int weight, int IQ, whatever. If you really want to, you can do this. Height is equal to weight is equal to IQ is equal to 0. That would set all 3 of those values to 0. The 0 gets copied into that, which gets copied into that, which gets copied into that. Do I take advantage of that? Nah, but you can. So that's multiple assignment.
Can you do it the other way, where you have int like x comma y comma z equals whatever you want?
If you do this, int x comma y comma z is equal to 0, that doesn't work, although I wish it did. That would be cool. All that happens then is that one gets set to 0, and then the rest of them are still undeclared.
Oh, okay. Well, it would make sense though
Yeah.
too. I got you.
I wish, but I'm going to delete that
What if
because you
put-
can't.
What if you put the X and Y and Z, if you put that in like...
Oh, exactly. Yeah, you could do x is equal to 1, y is...
Just like
Oh,
put
sorry.
Like parentheses X comma Y comma Z is close to parentheses is equal to 0. Would that assign all of
Oh,
them?
you're saying putting all the variables in
Yeah.
the parentheses. I'm trying.
I don't think that it would work. You could type that into Visual Studio and try it. I don't think it's going to work. So you're suggesting doing this, like that?
It doesn't work.
Okay.
It tells you that those are undefined. Even though you're trying to define them more. Wait, I forgot the int. Yeah, it says expression.
I'd rather do it like that, even though it's a little bit longer, just because that way I don't have to define my variables first and then initialize them with the second statement.
What's good for input variables, though?
Combined assignment. Combining assignment in other languages are known as compound operators. I shouldn't say other languages, other textbooks. If you have sum is equal to sum plus 1, oh, I'm wrong. I don't know why they're calling that compound assignment. Here's what I always thought was a compound assignment. If you did this, x is equal to x plus 1 is the same as doing x plus equals 1. They mean the same thing. Y is equal to y times 10. You can do this. Y times equals 10. That means the same thing.
Those are compound operators.
They are compound operators. This text is also calling this a combined, yeah, a combined assignment. So the compound operator is a way to pull off a combined assignment. So I hope that's clear. If you have int a is equal to 100, and then you do a slash equals 2, what does that give you?
Oh, wait.
Yeah.
Yeah, 50, it stores
Because-
50 back in there.
Right. 100 divided by 2 is 50, gets copied back into A. Is that good, y'all? All 5 of y'all agree? Okay. So those are the compound operators. Plus equals, minus equals, times equals, divided by equals, and even mod equals. So sum equals sum plus 1 is equivalent to sum plus equals 1. Now this can be shortened further. You add 1 and you subtract 1 in these languages so often that in C++ and Java and a whole bunch of other ones, but not Python, you can shorten that further. You could say is equivalent to sum plus plus. That means the same thing. Take sum, add 1 to it, put it back into sum. You'll see me type this a lot. You know, if you're writing a for loop and it needs to add 1 to x every time, or a while loop or something like that, then you're going to be using some, you know, plus plus or whatever, x plus plus in order to increment x. There's also an x minus minus. So let's make note of that. X equals x plus 1 can be rewritten as x plus equals 1, can be rewritten as x plus plus. X is equal to x minus 1. Could be rewritten as what? Doing it the compound operator way? X minus equals 1, and using the decrement operator. That's the increment operator here. Now there's some funny business about what happens if you put the plus plus before or after the x. For now, I'm just going to mention that that takes x, adds 1 to it, just like the other one did. But if the XX comes before, if the plus plus happens before the x, then it's the very first thing that happens in the statement. What do I mean by that? If you have x is equal to 10, and then you do print, no, we don't have a print statement. If you do print plus plus x, it's going to print 11. But if you do it after one, right, x is equal to 10, C out, x plus plus. It prints out 10, but x winds up being 11 afterwards. Why? If the plus plus is in front of the x, if it's a prefix, then it's the very first thing that happens before anything else happens in the equation. But if it follows it, it's the very last thing that happens. After both of these execute, x will equal 11. We good? Okay.
So like you would have to C out x, and then in another line you do C out x plus plus, and then C out x.
And you'd see the
11 instead of.
Right. If we did it good point. Let's add that to it. That's also 11. So prefix plus plus happens before anything else in the statement. Postfix plus plus, so plus plus x. Postfix happens after everything else in the statement. Does that usually matter? Only if you're trying to be clever. And what I mean by that is, if you have x plus plus, you put that on a line by itself, just because you want x to be increased by 1, it doesn't matter whether it happened first or last, But if you use x plus 1 or x plus plus as a parameter to a function, or as output for a cout or stuff like that, then it actually does make a difference. My preference is to make my code discrete enough so that every line has a different purpose. If I wanted to increase X and then print it out, I would do it in 2 different statements so that I can show it, so I know exactly what it's doing, and anybody else who's looking at it also knows exactly what it's doing. Formatting output. We're going to skip this slide for now, or this section. This is, just know that if you want to format your output, and what do I mean by that? To specify the number of places after a decimal point, or to say that I want this number to fill 10 spaces even if it's only one number long so that all my columns match up, you can do that. You just look up string manipulators. I'm going to make a note of that in my notes. We'll probably come back to this topic. String manipulators are used for formatting output, like specifying the number of decimal places, the precision, if we like using technical terms, of a floating point number, or how many spaces to pad out a number to fill a certain number of columns. Just because I'm skipping here doesn't mean you can't read about it. Set W. If you use set W and then you print something out, it sets how many columns that number is going to fill. Why do you do that? So that you can make them fill, so that you can make them line up in columns. You know what? I guess we really ought to cover it. Let's do it. Let's do it. Okay. I'm getting tired of all of this code that we've done here. So let's change this to int main2 and create a new main. I do that so that we only have one main in the program, and now we're starting fresh. Let's use a while loop to print out some numbers, and then there's squares. So like 3, 9, 4, 16, 5, 25, stuff like that. So let's declare a variable and set it equal to 1. And then we're going to say while x, parentheses, while x is less than or equal to 20, cout x followed by a space followed by POW, or just x times x, followed by ENDL. And then do an x++. So this is going to print in one column. Yay, the conversion happened. We have our video from last week. Alrighty, or from Monday. What this is going to do is it's going to print 1, add 1 to x, 2, add 1 to x, 3, 4, and as long as x is less than or equal to 20, it's trapped in the while loop. And so it's going to go all the way to 20, but when x becomes 21, it's going to fall out. I need to do system pause here so I can still see my output.
Could be any reason that if you have you're doing a while loop, but usually how you press enter, it keeps you in the same indentation. It's taking me out. I know it's taking me out. I've got my brackets.
Oh, did you figure it out? Good.
Yeah.
I'm getting an error when I compile. Let me look at my error list. Main must return a value. Okay, fine. Since I made this changed to main2, I need to make it return a 0 after the system pause. So, everybody please do make this change even if you're not done typing the other one. At the very bottom of main2, add return 0. And it's really weird that Microsoft lets us get away with not returning a value from main. We really ought to. We ought to just get in the habit of adding return 0 after pause. And from now on, I'm going to try to remember to do that as part of my boilerplate. It's declared to return a variable, a number, so the compiler shouldn't let me get away without doing it. Other languages won't let you be that sloppy. And why is this thing capable of returning a number? So that if you ran it from the command prompt or from a terminal or a script or something like that, it could return an error code back to the operating system that you could then check. So if it returns 0, you can say, hey, great, there wasn't a problem. If it returned a non-zero error code, you could have it, send you email saying, dude, your program broke, or whatever.
Oh, so and that's why main has to be an int, because
Right.
it returns.
So it can return something, right. Scripting languages don't return values to the operating system because the program runs inside the scripting language itself. So Python and Java do not. Java's not a scripting language, but you can't return things back to the operating system with Java, as far as I know. Okay, maybe this will work. So here's our table of squares. Notice that we have kind of a problem here. If we really wanted this to look nice, we wouldn't want it to look like that.
Need some more spaces.
We need some more spaces. Let's see if we can make it more dramatic. As well as printing out the square, let's print out the cube. Or even the, I don't know what you call it after a cube, the quadruple. So I'm going to change this to say x times x times x times x. Error, indel. I just added this stuff to it. Right there. Whoops, I forgot my fourth x. You know what, I don't think that's going to make it look that much cooler. Let's run and find out, though. Yeah, that's kind of stupid. Tell you what. Instead of x plus equals 1, or plus plus, undo that change that I just did. Make it say x, start it off at 0 rather than 1, and then add 5 to it each time. So instead of x plus plus, do x plus equals 5. Our numbers should get a lot larger, a lot quickly, more quickly this way. Oh, well. Okay. X, while x is less than or equal to 100, sorry for all the changes, guys. I changed that to 100. I started it off at 0. I'm adding 5 to it each time rather than 1. Those are the changes I've made. And I'll do walkabout to make sure that everybody's got it going in just a second. Okay, so you can see this is looking really lousy now, right? It's not spaced out correctly at all.
Put a tab in there.
Tab would fix it, actually. Yeah. If you wanted to fix it, you would change that to a tab. But that's not how that's not how the PowerPoint was going to show us how to do it. That's how I would do it.
I thought we just put a tab in there.
Yeah. So if you put a /t there rather than a space, it kind of fixes it. What do I mean by kind of? If your data exceeds a certain length and then you hit tab, it's going to jump over another 8 spaces. But that's one way to do it. I'm going to undo that change because I'm going to show you all how to do it the way the textbook did. Okay, so let me pause this. Make sure everybody. Without using the tab as our fix, what we want to do is we want to pad it out so that this one takes 3 spaces. That would pump that one over, and pump that one over. Or at least 2 spaces. We want this column to be 2 spaces. No, we want it to be 3 because we're going up to 100. So we need to change the width of the first number to force it to be 3 columns wide. To do that, we're going to need to bring in a couple of more includes. Or at least one. We need something called IO manip, like manipulator, manipulative. So go up to the top of your program and do # include IO manip. And here where you're printing, I'm just going to comment that line out to preserve it so that you can see the change that I'm making. Add that in front of the X. Looks like I've made a mistake. Let me see. Oh, okay. Like that. This is what I added right there. Or you could say that this is what I added. And then run it again. And we will see that it padded that column out to three numbers. And it even right justified them. If you want it left justified, you can change that. This one gets up to 5 digits. So let's add a set W in front of it to pad it out to 5 digits. And you know what I'm going to do to make this easier to read is I'm going to start breaking it up into separate lines. So like set width to X. And on the next line I'm going to do that. And then on the next line I'm going to do set width to 5 like that. And then on the final line I'm going to do that. Why am I breaking it up like that? Because this is one column and then we have a space between the columns. And if we set this to a 6 rather than a 5, we could even get rid of that. And now we have another column. And then we have our carriage return. And there we go. Now they're lined up like that. There are other I/O manipulators as well. There's one for specifying the number of, like I said, the precision of a floating point number. Because if you divide 1 by 3 and you print it out, it's going to say 1.33333, you know, maybe out to 6 places or something like that. But if you want all your floating point numbers to display with only 2 decimal places, then you could do that. So let's make some notes here. I/O manipulators. Don't do that. Okay. I/O manipulators change the output to make it prettier. Set W specifies the number of columns to pad the number out.
Can you do set W and put your variable inside the set W?
Yeah, if you want it not, if you put a variable in there, it's going to use that value. Like if you say B is equal to 10, set W B, then the next thing it prints out is going to be 10 characters wide. That makes sense because the number inside it isn't data to be printed, it's formatting information for the data that follows.
Yeah, so like if you put a string in there, it wouldn't work.
Right, right. But if you do set width and you print a string out, then you can specify how many columns you want that string to occur. So,
Well, I mean, like, if we were just to change it, instead of saying set width to 3 on this one, we just said set width to X on this, it would just make it where the numbers were all pretty much touching.
Now, if you set it to X, and since we're incrementing it and everything, it would
Just set
actually
both
make
of
a lot
them
of
to X.
spaces. That would be pretty big, because we're gonna get up to like 1,000.
let's run it.
How many bits that, yes, I was gonna say. That's what I was gonna say.
So you see what it's doing? The first time it was forced to fit into 0 columns, which if you exceed the length that's specified, it's too bad. You know, like if you say I want this number to fit into 2 columns, but then you try to print out 1,000, it's going to go ahead and print out 1,000. And then the next one got padded out to 5 columns, the next one got padded out to 10, and so on. I'm going to undo that. Heck, let's make them both 5.
Make them both X.
Nah. Okay. If you want them left justified rather than right justified, you put a minus sign. You know what? That's not true. I'm thinking of the formatting characters in Java and in Python. So forget that. There's another I/O manipulator you use to force things to be right justified. Let's look at the slide. Set width, we know what it does now. Here they used a little program, or they were probably set widthing it. We can go look. They were setting everything to 6. One thing to note is that you have to call it before every printing. You can't just do one set width 5 and then everything else you print after that's going to be padded out to 5 columns.
Is there not like a generic set width for? I mean, it just
Seems like there ought to be.
We're so lazy in that there's like so many shortcuts for everything.
Yeah,
that
it's.
there would be just like a generic.
You ought to, in my opinion, yeah. In my opinion, you ought to be able to set it once and it would stick. It'd be a sticky setting until you changed it. But it doesn't. Now the one that controls the width of floating point numbers, I believe that one is sticky. I believe that once you set the floating points to have like 2 decimal places, that it stays that way. Okay, so some affect values until changed again. If you do fixed, which forces decimal notation for floating point numbers, in other words, it won't switch over to using exponents if the number's too large, that one stays set until you change it again, unlike set width. Set precision, when you use it with fixed, it prints X digits after the decimal. Without fixed, it prints floating point value using X significant digits. I never do that. Okay, so let's go ahead and use fixed and set precision in our code as well. And then we probably will be done with these things. Let's make a different variable. Double D is equal to 1. While D is greater than 0.0000000001, then we're going to loop. But we need to see out the manipulator that says fixed, and we need to see out set precision, and how many numbers are we going to limit it to? I say 4. So let's see out now. I'm kind of spacing on what I really want to do here. Change that D is greater than to just while D is less than or equal to 10. And what we're going to do is we're going to see out 1 divided by D. That'll just prove the point. And then we need to increment D, so D++. It's complaining because I keep forgetting to type my L. I swear I'm typing it. I'm going to blame everything on the keyboard. It can't be my fault.
That's how I feel when I know it's not fun.
Yeah. Okay, and you see that it's printing them out to 4 decimal places. Comment out this fixed and set precision stuff and run it again to see the difference. There, So if you like being able to specify the number of decimal places, then use set precision and use fixed.
And if you don't use fixed, what it's saying is set precision is gonna, it's how many
Significant digits, right.
And the significant digits are the ones after it, or is it before the decimal?
Significant digits are,
There's like rules.
if you have like this, that's 4 significant digits. If you have this, that's also 4 significant
I
digits
should remember this
from chemistry and
science.
physics.
Yeah, it's chemistry mostly.
Leading zeros don't count as significant digits. Trailing zeros do.
I remember this. Now I remember. Chemistry is probably my favorite science class.
Oh yeah?
Well, zoology, I like
Mine too.
dissecting. I like dissecting that. That was fun.
Well, chemistry is close to alchemy.
They wouldn't let us do anything cool in chemistry. Like, we weren't making anything, we barely made anything that foamed or anything. I was like, I want to blow stuff
Nothing,
up.
nothing explosive.
Right?
Okay.
Milk and chlorine.
So, set width specifies a number of spaces. Fixed causes floating point numbers to be displayed in fixed point, meaning that you're not specifying the precision, you're specifying the number of decimal places. Show point causes a decimal point and trailing zeros to be displayed even if there is no fractional part. Sounds kind of like fixed and set precision. Set precision sets the precision of floating point numbers. Left causes the output to be left justified. Right causes the output to be right justified. What does that mean? Well, when we ran this, these numbers are currently right justified, meaning that they head up to the edge. If we wanted the numbers to be left justified instead, we could do that. We would just have to, let's go back to our code, and then we're going to need to take a little break in my opinion. I don't think we have to do it every time. I think we can just do it once. So, up here above my while loop, I'm going to see out left and hope that that left justifies everything. I could be tragically wrong. Nope. They're now left justified. They jut up against a left margin rather than a right. You just kind of have to decide what makes it look prettier to you. I kind of think things often look better right justified. So, you have to pound sign include what to get these things to work? IO manip. What's the one that sets the width? Set W. Sets the output to fill 5 spaces. Pads it out, whatever you want. Fixed and set precision. Sets floating point numbers to have 5 decimal places. 5 places after the decimal point. So if you do C out, set width 20, followed by fixed, not that you have to do it that, followed by set precision 2, followed by a number 1.33333, followed by ENDL. What is that going to print? How many columns wide is it going to be, and so on? Is it going to be left justified or right? It's going to be right justified because we didn't specify left. How many spaces wide is it going to be? 20. So it's going to be 20 spaces wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Why didn't I make it 10? All right. Now, how many decimal places is it going to have? 2. So what is it really going to print? It's going to print 1.333. So let's delete 4 spaces. 1, 2, 3, 4, 1.33. So it's 20 spaces wide. Right justified by default. 2 places after the decimal point. We good on that? Anybody get any syntax errors that we wish we'd fixed before I kept blathering?
You have to use the IO manipulator methods in your like string statements, like your cout and stuff, or can you use them out of it?
Oh, you can use an IO manipulator to modify string output. I'm not sure that's what you're asking.
Oh, I'm just saying like how you have cout and then you have all of the methods, but can you use them like out of CL? I guess.
No, no.
'Cause they're all
They
just-
mean nothing unless they're being sent to an output stream.
Yeah, that was my question.
They won't give you an error, I don't think. I think if you did this, I could be wrong, but I think if you did this, set width 20, semicolon like that, and treated it as a command, I don't think it would do anything. I'm not even sure it would compile, but I think it would compile, but just not do anything. Be kind of neat if it did. But you have to send it to output before it'll make any changes. All right, guys. Let's come back in about 5 minutes, 8:56, whatever. If you need to get a drink, need to use the bathroom, I do need to do one of those two things.
Problem is with CN, but what would really be a problem with get line? 'Cause I know they were saying if you use CN and CN.get or something together,
Then you can get into the same kind of problem.
but using get line.
Using getline, I was totally not expecting that to be a problem, and yet it was. So I can't explain why. What I would ultimately wind up doing is I would use getline for absolutely everything, and then once they typed in a string, I would convert it into an int or a float or whatever if I had to. That would make these input routines a lot safer to use. And I do the same thing in Java. Because in Java, if you use next int, but they type in a string, it breaks the program.
Yeah.
So I always use getline and then do the conversion myself, and if they've typed some bad input, then I can catch it. Okay, so I know that I was scrolling up and down and messing things up. Who needs help catching up? Are you good? Okay. Did I break your brain?
Yeah, kind of.
So you're good. I hate the spelling of the word length. It's actually TH. So yeah. Because if you start using height and length, you expect them both to end in T. How odd. Go clean it and rebuild it. There, it went away. You good? No.
I just added this because it was like, it was ignoring what I put in there beforehand. But I think I added too much. I just added these 2 lines.
No, I thought, to make it look exactly like mine, get rid of the clear. And get rid of the clear there. And let's run it and see what it does. Oh. Close that. Close. We're doing it in, okay, I was wrong, I'm sorry.
Yeah, I knew we were doing this down here, but once I started doing stuff down here, it started not to
Yeah, I was wrong, I thought I had spotted an error, and I don't see one, so let's see how it works.
Why did I do that?
I don't know. Let's go back to the board again.
And what did you say your issue was with get line? What was the issue with get line?
I'm not sure of an issue. you would only use it to read in strings.
Oh, okay.
Ints.
Okay, never mind.
All right, interschool.
See, it doesn't do the state. That just doesn't matter.
Exactly. But that's to be expected. That is the expected output. The reason why is we didn't use get line here. We just read in with CIN, so it only grabbed the first word.
All right.
Yeah. We all good? Onward and upward? Ew. I really thought we were going to get done with chapter 3. You can add strings together. So, if you do this, string FN for first name is equal to Sam, and then string last name is equal to Struthers, whatever. I don't know why that came to my mind. And then you could do string full name is equal to first name plus a space plus a last name.
And the reason I don't like doing that is because then if you want to print out the length of your full name, you can't just do length of full name because it counts the spaces.
It would count the space
So
as
that's
part
why
of the name.
I was upset because I was like, why is this saying that I have 11 letters in my name when
But it was 5 and 5, and it seemed to add up to 11. Yeah. So this is called concatenation. Plus, when used with strings, performs concatenation. Adds them together. So at this point, full name equals Sam Struthers. Library functions. Besides POW, you have sine, cosine, tangent, square root, log. If you want to use those, you have to use CMath. I don't think I have any questions in the quiz about CMath. That doesn't mean that we don't need to learn it, but it means that if I'm trying to get to it in a panic before we take the quiz, then I don't have to do that. All right. And like I said, take the quiz, I'll grade it. You can look at the answers that you got wrong, and then you can redo it, get 100 or whatever. And it takes the higher of your scores.
So what do they want to translate?
I don't know. All right. And some of these things you could just type in to figure it out. Like this question. I mean, I don't recommend that if you have to take a class, an exam in class. Typing code in and running it to get the right answer is going to take you too long. But here's an example of a question. Assume the following code: int x, cin arrow arrow x. What will x be if the user enters 3.14?
Oh wait, nope, not 3. It wouldn't.
It would be 3.
I thought it would throw an error. Because they're trying to store a float and.
Let's find out. Like I said, we're allowed to do that. Okay, so cout, enter a number, int m. I know x is defined elsewhere, so that I'm using that. Cin into m, cout m. Let's find out what happens if we type in a decimal point when it's not expecting it. 3.14. And it printed a 3. So it ignored it. It ignored the everything after the decimal point to get it to fit into an m.
What happened to the whole slide explaining that you can't, well, it did say you could degrade or whatever.
It did demote it to fit into the proper type. When I said it doesn't do any demoting, I was wrong. If you do this, m is equal to 3.14, it goes ahead and demotes it. Unlike other languages where you have to cast it to get it to demote. I would prefer you to cast it anyways, just to get in a habit for the languages that do require it. Okay. That was to illustrate that you can solve some of these problems by typing them in. I'd rather you know it well enough that you don't have to do that. But if you're puzzled over it, it's okay to do that.
Yeah, I was just confused because I thought it said you couldn't float in the int, but okay.
Java would crash if you did that.
See, I just got done looking at Java PowerPoint, so I probably will.
Yeah, yeah. When you're learning Java and C++ at the same time, they have a fist fight in your head. Okay, here's one of the questions about math functions. What does the pound sign include you use to access math functions? Well, we just saw that. It is CMath. Let's see if there are any others. To use the RAND function to generate a random number, what pound sign include do we use? That was Monday's lesson. You can look in our notes for that. Or another cheaty way to do it is to Google up RAND C++ and find an example of it, and it'll tell you which library you have to include. But it's better, anyways. I shouldn't tell you too many ways to cheat.
I thought that was already, I thought that the RAND function or method was already in the using namespace std, but to use like sran and all that stuff, we had to import a different, or include a different.
I don't know about that.
Wasn't it like CLib or something like that?
Yeah.
Because even when you just Googled it, it was showing it was in the std library.
All right, some people have turned in D&D characters already. Let's go look at one of them. C standard library is what you use for the random number generators, and then C time gives you the time function. Now, if you're saying that RAND comes by default, let's find out if that's true. Let's go back to our code here and do int x is equal to RAND. Well, no, we've already used x elsewhere. Alrighty, so you're right. I wonder what I put as the answer to that question. When it asks that question, go ahead and put in C standard lib, even if you get it by default, okay? Or if you type in the whole phrase, I don't have to have an include file, I will correct it, but you'll get it right. Okay, so RAND function and srand, let's pretend that they both require C stand lib. Adrian just pointed out that RAND comes in by default. Right, okay. And then time is in the C time library. I/O manipulators require which one?
IO manip.
Yep, I/O manip. CIN and cout and ENDL.
IO string.
Really, like the basic C++ language lacks a lot of the things that you actually use the language for, and I don't understand that.
But, like if you're going to write, controller software, for your car or stuff like that, you want it to run in as little memory as possible. So by putting all that stuff into libraries that you can optionally bring in, then the executable, if you don't need that stuff, is smaller.
It makes sense, but then I guess my question.
But then it's annoying because you have to bring in something for every function you want to use.
What can you do without importing any libraries is kind of my question. Like,
I mean,
what
those
does
libraries
C++
came from
do?
somewhere. Those libraries were constructed by people that used the language to build them, right?
Right. So somehow those libraries also are based on the C language. And then the question becomes, how in the world does CIN and COUT work? How would you do the same thing without it? Really good question.
Because like everything that I know about programming, about getting input, getting output, and doing something with that input, it's like that stuff's not included in just normal C++. So what possibly could C++ be used for?
So
without all that stuff?
let's include CMath and then do RRR is equal to the square root of RRR. And the only reason I'm doing that is because I'm hoping I can then go and find the source code for the square root function. So I'm going to right click on that and go to definition. Well, that's certainly not telling me what I was hoping to see. Where can I find the source code? No, that's for Java. My answer is I don't know.
That's how I just go and say, what can you do in C++ without imports? And
Yeah.
it's like,
Okay, I was validating what is in the quiz.
Why don't you look up how to input without IOStream?
I did, and I think what it's all command prompt stuff.
So, how to write Hello World without IOStream.
That's exactly the page I'm on.
Right.
Yeah.
Oh, come on. Okay, they're pretending you have to do it with assembler. That's surely not.
24 lines of code just outputs only one line. Oh, can we get C++?
Okay, some libraries talk directly to the hardware. So yeah, that could be it. Some of the libraries may be written in assembly, and then they're just giving you headers for those functions, prototypes for those functions. We'll hear of what those mean, and they're just wrappers for that assembly code.
So IOStream's in binary then?
It's written in assembly. Ultimately, everything is in binary. Once it's saved to the disk to be run as an executable. But assembly is an intermediate form. I hope I can find that slide again. It's got these little abbreviations, global and move and stuff like that. These are opcodes for the chip, and then a program called an assembler goes and it converts all that to numbers to write, to link into your file. So that's a low-level language. This is a low-level language, and C++ is a high-level language because it's got English-like syntax and algebraic notation. There are what I would think of as being higher level, you know, but okay.
Like GUI input, GUI programming or something?
You have to use libraries to do that. Pity the poor Windows 3.11 or Windows 3 programmers or 95 programmers before the libraries were invented, because they had to do stuff like that. But eventually libraries, were created to make all that easy to do. And so those libraries encapsulate the complexity of drawing GUIs.
Well, I mean, just like, have you know, like the IDEs that like the interface is a GUI interface where you're programming with the GUI.
Right. Yeah.
Which is just crazy. It seems redundant almost. It's like, here's this program to help me program programs.
Right. And you don't need the GUI in order to write C code. You could write it with a text editor and then run the compilers and the linkers by hand. Another funny thing to think about is languages are usually compiled using that language. the C++ language is written in C++. So that's kind of a weird bootstrap thing. And the way they do it is they write the first version of the compiler, a very, very primitive version of the compiler, is not written in the language. It's written like in an assembler. But then you use that to compile C++ enough that you could write the language in C++ and compile it in C++. It's a weird bootstrapping idea. Okay, let's finish stepping through this if I could find it. Set precision. Okay, so that was actually the only question about the math library is question 20, which is the # include you use for it. So I feel comfortable in just saying, if you need sine, cosine, tangent, square root, or log, you know where to go for it. Other functions. The C standard library. Random. See, it says it, even though, and then srand. So random returns a random integer between 0 and the largest int the computer holds, which is 2 billion, you know. And then srand initializes it with a number. It seeds it.
This is a standard library. You don't have to include it, right?
You got to, though, even though it sounds like it's a standard library. Java is the same way. There are some libraries that are brought in by default, but it's called the Lang, L-A-N-G. And then there are other, libraries that you might expect to be default, and then they're not. Okay, then there's something called trace, and there's something called a case study, blah, blah, blah. Well worth reading, but not part of the language. We are done with chapter 3 with a whole 4 minutes to spare. Yuck, yuck. I mean, not that y'all are going to complain if we have to hang out an extra 3 minutes. Let's find another assignment besides that print statement to assign, because that printing work, because that was a little too trivial. You can do that with like 4 changes to the code, if that, and be done with it. So calories program. Here's going to be the other homework assignment. Let me get the cleaned up version of it from last semester. It used to be worded really annoyingly. I stole it from another professor, and he had a different way of doing things. Y'all are a cool class. I like it when people talk. I'm going to have to start calling on y'all guys, though, because y'all are more extroverted than you guys.
Well, I don't know, like when it comes to, like, I guess Java and C++, I've just been, I guess, I don't know. The language just doesn't make any sense to me, but the only reason it doesn't is because since I started with Python being my introductory language, has all that stuff already integrated in it.
Yeah.
So it makes sense, and I thought, when I came to C++ and Java, I was like, well, the languages should obviously be able to handle input without having
Right.
another user-created library or something, but it
And
doesn't.
it doesn't.
So,
Right.
So my question is, when they first made these languages, what were they doing with these languages? With Java?
Well, remember that
Java.
Python is invented like 20 years after C++, which was invented 20 years after C or whatever. So, people figure out what would make a program, a language easier to use, and so they redesign languages. So that's, the original C programming language would have been used on a green screen terminal hooked up to a mainframe. And so all it needed to do was to display text on a screen, let users type stuff in to perform basic math, and then to write and read to files. That's
DOS.
Yeah, just like a DOS program that couldn't do any graphics or anything like that. That's what it was written for.
Okay, well then.
And then they just kept adding to it and adding to it.
But then input's already included, right?
A certain form of input is.
Okay, sorry.
I don't know what that certain form of input is anymore.
Okay.
I think it's called scanf. if you look up the scanf command, then it is something that does not require a library, I believe, and it'll read from the keyboard. Okay, and it's horrible. But anyways, so here's going to be the other homework assignment, the real one, not the table one. You know, although that's real homework too. It's half the assignment. Health and fitness software development. In this assignment, you will write a computer program that asks a user for information. The program computes the number of calories they are burning each day and displays the results. So you're going to have to ask for 4 things. You want to ask their weight, you want to ask their height, you want to ask their age, and then you're going to ask for an activity index. An activity index is a number like this. If you're sedentary, it's 1.2. If you exercise a lot, it's 1.6. If you're Michael Phelps and swimming all the time, you're 1.9. And then you have a calculation. Here's a formula for calculating the BMR, known as the basal metabolic rate. And then the calories you use every day is based on the BMR times the activity index. If this sounds like a lot of information, just reread the instructions a couple of times. So here's an example calculation. Imagine a person weighs 135 pounds, they're 5.5 feet tall, they're 61 years old, and they're sedentary, so their AI is 1.2. The BMR for this is that, calculated by that equation, right there. And then the calories that they burn each day is the BMR times that 1.2, which gives you that many calories a day. All calculations are approximate. Okay, so a sample run. Okay, this is still waiting. Okay. To advance your health, we will calculate how many calories you burn up a day. If you don't want to put in all this fluff, you can simplify the way it looks. We will need data on your weight, height, and age, and what kind of activity you do. Please enter your feet, your weight in pounds. They type in 135. Please enter your height in feet. They type in 5.5. Please enter your age in years. They type in 61. And then it says these are activity indexes for different lifestyles. Please select yours. It prints out all of this stuff. These are just like 5 see-out statements in a row. And then there's one more. Based on this information, what is your activity index? 1.2. A cooler version of this program would be to say, if you have a desk job, enter 1. If you have, and then they just type in A, B, C, D, or E, or something like that. But this is the simplest version of it that doesn't require any if statements to handle. Here are the results from our computation. You burn that many calories a day. Thank you for using the row state. Okay, so that's the other assignment. It's really no more complicated than the conversion programs we talked about earlier, except it requires asking for 4 pieces of information, and it uses 2 equations. Hope that makes sense. We're going to make this one due not next Wednesday because we won't have had an intervening class between this Wednesday and next Wednesday since we have Monday off. It's going to be due the Monday after that. So let's upload this.
I have one more question and I'm done with questions. So like, I understand that some languages have like derived from other languages, but like, it all has, I guess, a root. It all comes from somewhere. So how does I guess when it comes to Java, how did they make Java more portable to like different things than
Well,
C itself?
they just sat down and decided we're going to make a language that meets these requirements. And the requirements were that it's going to run on everything from microwaves to cars to Commodore 64s to OS/2 machines to Windows. And then they figured out how to do that, which is to write something called an engine. And the engine takes a program written in a specific language, and then it at runtime turns it into an executable that your program can run. And so you have to change the engine for everything. You have to have a different Java engine. That's why it's installed. You have to install Java before you run it. That's the same idea as a game emulator. You're a fan of Pac-Man. You want to run Pac-Man on your machine. You download and install.
ROM.
Yeah, you have to get the ROM, which is the software, and then you need an emulator for it. And I can't remember the name of the emulator.
Depends. there's like a million.
Yeah. But there's a really cool MAME, M-A-M-E. So, multi-arcade emulator. And so that emulator is written differently for every platform. You can run MAME on on an Android tablet, or you can run it on Windows or whatever. But the ROMs that you play are exactly the same. And that was the goal for Java. And so whenever you're trying to solve a new problem, you just decide what problem you're going to solve, and then you start from the ground up.
And I guess I viewed it that way, and then I was like, well, how come they didn't just upgrade C the way they did Java, I guess.
Well, Java is based on the C syntax. It's very similar, yeah. And then there are some languages that are a lot less based on the C syntax than Java and C++ are. Okay, so we're going to have two folders. 5 is going to be the division table manipulator assignment. I'll upload the instructions for that later so that I can let y'all out of here. And then 6 is going to be the BMR.
I don't know if that's not ours, is it? Because we only have, we're up 0, 1, and 2 right now.
Hey,
1173.
Yeah, we're 51, 50.
what am I doing? You're going, I don't know. Yeah, I'm inside, 1113. Great. Okay, let me just delete what I just did. I don't want to terrify them. Okay.
They're like, what is this?
You guys hurry up.
Okay.
I think you did do that once for us when it was Java, and I looked at it and I was like, I don't even know Java yet.
Yeah.
Come on now.
Yeah. Sorry about that. Okay, so we're on homework 3 and 4. My mistake. 3. Division table with I/O manipulation. Four is the BMR assignment. And let's make a Dropbox for whatever CPP files you want to upload from today. And by the way, if you're here, upload a CPP file. Don't walk out of here without uploading anything, because you get credit pretty much for whatever you upload in the in-class. Because I know that not everybody may get everything typed in that we're doing up here, but even if it didn't work properly, please upload it. For one thing, that's how I count attendance. If you don't upload anything, I forget you were here, and I send you an email going, why weren't you here? And I know that's happened. Okay, so anyways, D is in class. And what did we do today? We did I/O manipulators. We did get line. What was all that other stuff we did? Flushing and
So we did a lot of casting. So
we did casting, but yeah,
it's not.
it seemed like we talked more. Wow, how did we spend 2.5 hours just talking about casting? And so there actually had to have been more than that, but I'm not really seeing it. Okay, fine. We're just going to leave it at that. I/O manipulation, get line, etc. etc. will cover it. All right, so upload a CPP file into in-class. I'll fill in the division table and the BMR with Word docs in just a moment. The due dates for both of those is going to be the 25th, which seems like a lot of time. But don't delay, you know. The earlier you knock these things out, the better. The only reason you're getting that much time on them is because if we're missing Monday, then you won't have had a chance to come in and ask me questions about them. That makes sense? So it looks like a lot of time. If you don't have any questions over them, if you can get them done, please do. A lot of times people can get stuff done the same night that I assign it because these are not huge programs. If you get the concept, it can go pretty easily. And it's okay if it doesn't, you know.
Yeah, I was kind of surprised how
Yeah.
Super simple. Actually, I wound up doing both of them in under an hour, and I was like, oh,
Yeah.
okay.
So then make it to where you can pick a class. You can arm yourself with weapons. People have,
Don't forget, pick your race.
yeah, people have been writing programs like that since the 70s. Ever since D&D was invented, people have been writing computer programs to play it, even if it was pure text.
It's fun to get D&D online.
I already told you what I want to do for my tax down, but it's like I'm neither C++ or Java or anything like I want to do my cap stuff, you know, because they're just I don't know, compared to Python, they're terrible. I mean,
Yeah, use the language you like the
Is
most.
Python really easy?
Yeah, the syntax is so clean, dude. It's just like it's not. It just makes all sense. It's like the most. Like I guess.
Sometimes you could type in like 3 lines of Python code that would take you 20 lines of C++ in order to get it done. And it's Java is my favorite language, but Python is my other favorite language for different reasons.
Fair enough.
Trivia question. What is Python named after?
For Monty Python and Holy Grail.
I believe it was Flying Circus. but okay.
Yeah, Monty Python's Flying Circus, and that's why the editor is called Idle for Eric
Okay,
Idle.
Yeah. Okay.
Yeah.
See you guys later.
All right.
Yeah.
See you next Wednesday. I will send a text out and an email reminding people not to come in. There will be a video posted. It will not be horribly long, but I don't want the day to be entirely wasted.
Okay. I had some questions about some of my programs.
Okay, cool.
I'm gonna go Google up why C++ is used for gaming.
It's fast. It
It's
compiles
fast.
to an executable very efficiently. Java does not compile to an executable. It's interpreted at runtime. It's the fastest, and the compilers for it are really optimized because people have been working on it for a long time. So the compilers produce really nice, fast code.
Yeah, Java's sort of used for like making web pages and stuff like that.
Yeah, for doing right. Exactly. So if you have a company, then you'll have Java programmers who are either writing desktop software or they'll be writing stuff that runs on the server to generate web pages.
I'd rather do software and web guy. But Java, I mean, I've heard a lot of people say that Java sort of would kind of be dead if it wasn't for Minecraft. But then I was like, well, I know a lot of people still use it in the workplace, so it's like.
It's still very popular as something that sits on a server.
It's because everyone mods Minecraft.
That's the only reason, because that's the only thing you gotta use.
It's the same with Skyrim. Everyone